Hi there everyone, Cody Don here. Welcome back to my lab. So today I've got about 200 of these N52 iron boron neodymium magnets. You see they're about an 1/8 inch tall and a 1/4 inch wide cylinder. They're very strong for their size, and they're quite fun. And while playing with them, I've sort of noticed that they resemble molecules, you know, the way that they snap together. So it's almost like you've got a really polar molecule, see, that will connect together with another polar molecule like this. It'll slap together, but if you bring it together the other way, it's not exactly like a molecules, but this is rather similar to how something like that would arrange itself in nature. See, like this right here would be the crystal structure, the planes in the crystal, things like that, you know, a whole lot of things that is very similar to actual crystals here. One thing is, if you heat it up, you know, give it some energy, you know, kind of like that, you get it stirring. You can see now I've melted it, so now it's sort of a liquid. And then when I stop, it attempts to reorient itself into its fibrous crystal form. Yeah. But another thing is, I can actually sort of simulate a gas here as well. See, if I take two of them and line them up so they're facing the same way and the table's like forcing them to stay in the same orientation. Okay, bad example. There was a chemical reaction there. But if I force them to stay in the same plane, then they actually repel from each other, kind of like that. So now what you've got is a lot like a gas. More specifically, this would be how a gas would behave if its critical temperature was absolute zero, which of course nothing does that, but we can approximate like air molecules with this. You know, in reality there would be some sort of attraction, so if you slammed them together all the way they would eventually stick. But yeah, see, they're not going to do that. But while they're still out here, they kind of do have a bit of a repulsion, which is sort of similar to how gas molecules behave. I mean, gas molecules don't really repel from each other. They just sort of, they're bouncing around so much that, you know, they're usually just bouncing right off of each other. And the speed that they're going, if it's above its critical point, is more than the escape velocity required for the weak interactions between them to pull it back. Okay, so I want to try something with these, very similar to what I was doing there on the table, but sandwich them between two sheets of glass. So I've got some aluminum spacers here, cut the size. I'm just going to stick these there and there. I'm going to glue them in. Okay, it's time to start putting in the magnets. Wait a minute, they don't fit. What is this? So I've added a couple of sheets of paper to shim it out a little bit more. It's a good thing super glue is easy to remove. That's sarcasm, by the way. Let's they drop straight through. Good. Okay. I love how they bounce. See that? Well, looks like it's working. So there we go. All but just a few left now to put in. Oh, I just put one in wrong way. You can see what happened is two of them stuck to it. Actually, if I move it around a little bit, just using this, you can see it'll stick to three. If I push really hard, I can actually get a fourth one to stick onto it, but it's kind of hard to do. It's basically like a big gas molecule there. So you can really see here that the ones up here have a lot greater average distance between them than the ones down here. See that? It's because there's more pressure down here than there is up here. Now, I said that these act like gas, but you know, you can see they're obviously not filling the entire container. But if you think about it, gravity's really holding this gas down. So it's as if you've got the top of the atmosphere right here. But if I reduce the strength of gravity, you can see that the gas particles can go much farther up. See that? Of course, they aren't gas, so that's the thing. Anyway, I might leave this out just so that I can sort of play with them a little bit. I can certainly use it to help move this one right here around. If I can grab a hold of it, I can just pull it up out of there. So yeah, I think this is pretty cool. Well, now I wish I wouldn't have tested it before filming it. Okay, I guess I'll try again.